Round 3. Fight!
Woo-hoo-hoo-hoo. Here we are.
Hey everyone, let me show you the registrator of the Marble Machine X. Here it is. And for a long time I've been thinking about how to make a much better one. And this is the purpose of this stream. I'm gonna show you my idea and I'm gonna CAD that, and it should be a pretty simple project. Hope you're doing great. Let me tell you what the problem was with this one. As a little reminder, this is the Marble Machine X to the right there. And you can see at the top of the machine, you can see them kind of sticking up there. So let's look at this registrator. How are you, by the way, Hannes?
Oh, I'm so good. Just waiting for it. I'm perfect. I got my thinking oil freshly brewed right here.
Cheers.
Ready to dive deep into this solution you got working on right here.
This morning stream was a horror show, and I want to take revenge in getting something productive done. It was right out horror show. I've been like bathing in my own shame during the lunch break. Let's get something much better done. So the system, this thing right here needs to be adjustable. And this is my improved design that I'm gonna make today. How to adjust this, because this little that looks like a foot here is the thing that interacts with the programming wheel, and we want to adjust it sideways, which will give a very, very nice way to adjust the timing of the music. So we needed that function, but the way we designed this on this machine is that we had shims behind here. So this little gray part here is a metal shim, and you had to unscrew the screws here. The screw holes are not in here because this is from the another CAD model than the one I did. So the holes are gone. So you had to screw, you had to take this part out, add another shim, and you had to put it in again. And what happened is that the height position of this did not end up the same way. So involuntarily, when I adjusted the timing of the thing, I couldn't repeatedly put it back in the same position with just one change. It also went up and down, left and right, and it was a huge mess, and it took a lot of time, and it was not user-friendly. I thought it was like a one-time setup. So for a long time, I've been thinking about how to do this better, and this is the first sketch, and I'm going to block this design idea up. And an important thing is that the programming wheel, the programming pins are moving at a curve. So let's make a fictitious programming pin right here. So this is it. And if you think of the surface of the programming pin rotating around the programming wheel, this construction line here will represent the movement. I want to shift the registrator position along this curve. So regardless if I shift it, it will always hit at the same angle. So if I exaggerate a little bit, if you think of here, the programming pin will tilt like this. And if we shift the registrator backwards, the programming pin will tilt like this. So what I've come up with is to use a slot that is curved with the same radius. So this slot is not a rectangle, it's actually a little banana shaped along the surface of the programming wheel. Nice, huh?
Yeah, and no rectangle patterns.
Absolutely no rectangular patterns. They have been forbidden. Banished from the surface of the earth. So I'm going to you know what? Let me just block this a little quickly.
Do it, and I will just say greetings here from Sebastian Hornbeck. He says it's nice having these streams running in the background while working from home. Keeps one reminded about getting hydrated as well. That's right. We bring essential functions to your life, right? Not only just catting here, also reminding everyone to stay hydrated, even if we forget sometimes, because it's too much fun doing these streams.
I've been drinking so messily on the streams, and I was like, why am I doing that? And I realized that I've been trying to drink faster than I normally drink. So I've been like pouring water all over myself. And so another stream objective for today will be to like drink slowly once I'm drinking. I'm sure there will be time for that. So,
and I just want to say Satish Kumar 5, love the yellow shirt, my favorite, Hannes, mine as well. And all of you can own one of these very beautiful yellow shirts. We have them up on our website, wintergatan.net, if you want a cool Pain is Temporary, Glory is Forever shirt.
Fantastic. I think it looks awesome on you, Hannes Paradis. So I am just cutting this. Okay, and this should be a little bit more like that.
Oh, here comes a deep cut joke from the earlier stream this morning. RB Produktion, spring rolls for lunch? Question mark.
Wait, that is too genius for me to understand.
What did we do in the earlier stream today? We meddled with springs. Okay.
Okay. Now I'm with you. Now I am with you. Brilliant.
Brilliant.
You know what? Let's remove this. So I want to make a blocky version of this to show you the idea. So I remember when working on the Machine X, I was standing behind the ladder trying to fix these things, and it was an absolute pain. New component, side. I'm just gonna call it side. I'm gonna export this, extrude 4 millimeters. Doesn't really matter. Let's give it some chunk. 6.
Oof.
And then we want to copy this part. I'm just gonna pull it over for the sake of argument. 22, something like that. And then in the master sketch, we are going to give this wall a little bit of a thickness. So what I want to have is a set screw. One single screw that are accessible at all times that I can turn with a screwdriver that automatically adjusts the timing. No parts coming loose, nothing to disassemble, just a classic set screw. Turn clockwise for earlier, turn counterclockwise for later timing. And that's how you will control these. And I think that's something that I learned the hard way when I become a better designer. With 10,000 parts, if all of them are hard to reach, it's just going to be a horror show yet again. So in this, let's a little ugly. Children, close your eyes.
Oh,
Good.
Mr. Gonsonator is wondering, will the registrator travel be shorter in this version?
Not sure yet. I don't know yet. It could potentially be shorter because we need less. I mean, shorter would be more precise, I guess. So yeah, I don't know. Can I move this over? No, I can't. Doesn't matter. It doesn't matter for the purpose of this discussion. Oh, that body ended up there? Okay. Let's redo this. Let's actually delete this thing. I'm just going to clean up my act a little bit. Let's copy this body instead. 22 millimeters, boom. And let's now extrude this while we're in the correct component. So we can join these together. Join, good. So on this surface, I'm gonna cut a slot for the set screw. So this is where you will access the set screw from hopefully from a good simple direction of the machine. Looking for the middle there. And then I'm making a center slot, center point slot. There we go. This is honestly more productive work than I did in the whole first stream. That's not true.
Nah, stop now. We learned something at least.
We learned something, but it was painful. But
we learned that we know nothing.
That's one Socrates thing that I think is like very prescient. I know that I know nothing or something like that. All the Socrates quotes are misquoted, so don't at me.
Don't come at me, bro.
Don't come at me about Socrates. I know. Since I only know that I know nothing from Socrates, I also don't claim to know anything about Socrates. But Greek, I do think Greek philosophy got a bad, like Stoicism, they call it West yoga. And yoga, like in Eastern countries, were uninterrupted by religion, where in Europe we had like Christianity coming and pausing like Greek philosophy for like 1,500 years. So I do think that the Greeks had some really great points.
But did they build a marble machine though? No, they didn't.
That's true. That's true. They built a lot of marble statues.
That's true.
You know, I went to a radio interview once in Swedish national radio.
Yes, please tell this
and
story.
The journalist was like, okay, so you built a marble machine. Where did you get all the stone from? I was like, stone? Yeah, all the marble stone. And isn't the machine very heavy if it's built from marble? And you're like, mainstream media, thank you so much. So here's the kicker. Probably a lot of you Gretzkys have already skated where this puck is going. Now I'm going to sketch the little Delrin part that will slide in this slot that will actually touch this programming pin. So we can give it any shape. Let's just say that it's this shape for now, for ease of construction. Let me give it something like this, something like this, and I haven't thought this through. It's mainly the design principle I want to try on CAD and I want to show all of you. I thought about this so much and I kind of got this idea like yesterday or today on like, oh, but this is a simple place to start anyway. So this is probably Delrin or POM. And now again, yesterday we talked a lot about the offset feature of the extrude command.
The command so brilliant, you want to marry it.
Yeah, there was a person in chat wanting to marry the offset feature, and I totally understand why. So let's call this reader, POM reader. So now I still only have one sketch in one plane, but thanks to the offset command, we can do extrusions where we need them. So if I take a look at this from this perspective, and I can zoom in and show you with my new higher zoom grade. Look at that. That's Enhance. So start is going to be an offset. And we built our wall 6mm thick, so let's offset it 6mm, I think. And then let's make it 10, no more. Was it 22? No, 22 minus 6. There we go. So now I've extruded this exactly in between. Boom. And now this part sits in between, away from the sketch plane. Let's paint this Delrin black.
Oh, paint it black.
Paint it black. Now again, we're going to make another extrude because these are going to be the things riding in the slot, keeping the part in the slot. So I'm just going to extend this to this side. Boom. And we're going to join. Boom. So if I hide the sides, this is what we have now. A little nice little part, but we're not done yet. We, of course, need the set screw.
Of course.
Yeah, I don't know why this was so funny. Maybe because I'm more light-hearted now.
Yeah.
I didn't know how to act the first stream, if I should try to express my frustration or if I should realize like there's larger troubles in the world.
Yeah.
It looks a little bit oversized, but that's okay. That's okay. Let's now cut a hole in the... Let's isolate this. So these small differences are going to make... this is like why I wanted to start over. Like, do it again, do it right, kind of thing. So what kind of fastener should we use? M6. This is way oversized everything. This M4 would be enough. Let's put M6 right now. So this is just a through hole, and then on the back side here. Oh, I almost put another sketch here. We don't have to do that because of the offset command. I can use, this is a whole reason. So if I show you timeline, we can reuse this sketch that we already have.
Offset.
Yeah, because of the offset. So let's make a little polygon. Circumscribed polygon. And I don't care about the size now. It doesn't matter because this is just blocking to show the idea. And now we can extrude that little polygon. But we don't have to extrude it from there. We can extrude it from wherever we want to. So let's offset it. Offset -12, -20. Distance to object. We want to cut to here. So there you can see a nice little nut retaining cavity.
Du, 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 du. Du, 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 du.
Are you playing the wedding
here we
song for the offset command?
Go.
Let's add some fill. Let's people think I can CAD. People will think. What a difference a lunch makes. Just 1 little hour. There we go. POM. And what happens now is that now we need a little fastener.
Fasten your seatbelts, everyone. Yee-hoo!
And I'm going to not import it. I'm just going to...
And chat is screaming here now. How will you insert it inside?
Good point. Good point.
Gretzkys are on the puck as usual.
So this is not... okay, good point. So either we open the thing up here because it will have enough. Good point. If we open it up there, we have a longer travel. Let's do that for now. Yeah, Gretzky's in the chat, skating where the puck is going. I love that so much.
Oh no, someone has seen through my charade here. Alexander Weichselbaumer. Kudos to Hannes, who has no idea what you're doing, but still supports you. Oh no, the ruse is up. Oh no.
That is honestly 80% of our audience. Boom.
Oh, wow.
Just joking, just feeling victorious. I have a what is happening here? Why is this? What happened here? I don't like the yellow sketch in the timeline. Review warning. Compute failed. Oh, yeah. That's no problem. What? Sometimes it helps. Yeah, this is clearly... Maybe it helps if I just do this. Oh, it's not a whole profile anymore. Why not? Did I not close it there? Weird. So now when you see that this profile is not whole, you can always pull a line over and see where...
Hans Brech says here, just screw the side blocks in and cut them off.
Screw the side blocks in and cut. With... Oh, you mean you screw them in? I have to fix my sketch here. Something is wrong with my sketch.
Fix your sketch, man.
Yeah.
Come on now.
Fix my act here. What is happening? Honestly, Fusion has been acting up today.
A bolt and a nut. Lord Socks on Discord.
It's gonna come a bolt and a nut. I'm just trying to find why my sketch thinks that this is not a closed plane, because it is a closed plane.
Isn't it because you have a line that have no material in both sides?
Oh, well, look, even when I draw a circle, Fusion says that this it doesn't recognize this as a thing. Let's see how this sketch behaves in another design document. See, it should become blue like this. But over here, yeah, I'm going to save this file and I'm gonna close it and reopening it, because this is ridiculous. Save. I'm just gonna reopening it.
Perfect time for me to read this beautiful message right here from Mandracool. I just want to say thank you. I got COVID over the weekend and I've been in bed with a high fever since yesterday. I'm so glad you guys are streaming because it makes my day feel a little bit less miserable. Heart.
That's nice to hear. I hope you have a quicker recovery than I had. It was like, I wasn't that sick, but I was like bad for a long time.
Yeah.
Okay. Let's make another sketch. Just to more info. Compute failed. Failed to generate profile as curves do not precisely overlap. Here is a good. I think I can show you that.
Enhance.
Curves do not precisely overlap. I think something happened. Okay. Look at that. Sometimes Fusion goes crazy. I just adds 2 lines and now it's back to working. That feels buggy. So I have a hard time knowing when to blame Fusion.
And we've learned always blame Fusion.
Here we go. Now we're back in business. It was a strange bug. So I'm gonna cut this out, and since we have so many Gretzkys in chat that are skating where the puck is going, they foresaw this issue, and now we can just slot this thing in. And we also gained a little bit of travel. I mean, this is not like super neatly designed now. I just want to show everyone the principle. So let's make the bolt. And a nice way when you want to find like you want to make a bolt in the middle of your design, because I haven't made it around the mid plane, is that you go up here and you choose mid plane and you just select the outsides of your thing and you get a plane straight in the middle of it, and we can use this for our revolve sketch that we're gonna make. So I wanna get this little line. I want to get this line. That's basically all I need. What happened with that line? Project. Thank you. And then my new favorite way of making all cylindrical shapes is to cut them from the side and revolve them. So let's do this. Let's do this. Let's do this. Let's do this. So I'm cutting half the bolt here. And I want this line to be parallel with you.
I always love it when you show these tricks and tips.
There is something about, I know like a lot of experienced catters might roll their eyes because it's so extremely basic. Still, it's a good, sometimes you have to just get back to basics.
You can quote him on that, boys.
The screw head is 4mm thick, and this is gonna be coincident with let's do it like that. There we go. And there we go. And now we're going to do the revolve that we've been fawning over for some time now. Not of you, but of you, and of you, and of you, and of you. And there's our strangely shaped screw.
Wow. Booyah.
Let's make this head a little bit less humorous. Like that. You know what? Boom. And I mean, to make it painfully clear, let's add a hexagon here.
Oh, yes.
Polygon, I mean. Boom. I'm not even going to center it.
We don't need that.
No.
Oh. Oh.
And there's different ways to make the screw stay in place, but I think one of the... So you can have a compression spring here, which I think is very classic. And you will need a nut here with a lock nut to make it not spin. I'm scared of a compression spring. So I don't really know how to retain the screw position without a compression spring.
Is this you could use a smaller screw if you used a set screw from the side?
Use a set screw from the side.
Yeah.
So from the side here, you can't access because all the registrators is hiding each other. I think that doesn't work. I don't know how much travel we need on this adjustability. But another way to make this screw stay where it is, maybe just a lock nut. So normally you would put a compression spring between these two surfaces. That would like look good. But I'm scared of that moving range. So
Also, Chris Simmons here writes, suggestion, try to use standard length of bolts and screws at this stage. It will save you having to chop down potentially hundreds of bolts in the future.
yeah, so I totally agree. On the first machine, I used the bolts in CAD. I'm not going to introduce bolts. And we did standards, and I spent a lot of time on that. This time around, I'm not going to... Normally, I'm not going to include the bolts in the drawings. I'm only doing it in this one to show the function.
Okay.
But I totally agree with you. If I'm going to include them, I'm going to look at sizes and stuff. So if you put a strong lock nut here, but I wouldn't trust that. So now the question is... how to retain this. Like, I almost want to build a cage for this.
A cage?
Yeah, a cage.
Okay.
How could we do that? Okay, so chat, what do you think? I'm gonna show you the options. I'm gonna make the coil, the compression spring, which is the classic thing way. So spring, create a coil on this surface here, like this. This will get a lot of votes because it feels right, but I'm worried about the range.
Lock rings, cross pin.
Cross pin.
Ring with a cross pin.
That sounds good. What do they mean, actually? So this is alternative one, a spring right there. I don't want to do that solution. A cross pin. Basically, we need to stop the bolt from moving to the left in some smart mechanical way. We can use that. We can use a maybe like a nut with the strongest, like super low tech would be like a
Hex bolt.
hex bolt on the inside here, and then somehow. But I don't want to rely on friction fits. I want to rely on mechanical fits. It's a big lesson from Marble Machine X. So. But anyway, let's present this as an option. New component.
Cotter pin.
Stack bolt. Cotter pin. So let's use the same sketch as we used here to just CAD the... No, let's not. Let's use this one.
Cotter pin is something like this.
Ooh, yeah. The first one to the left there.
With those.
Yeah, this is... Yeah. That is pretty nice.
Jairo Cabello, this deserves a new section in the Google Sheets file.
Please create it. Good idea.
First, last name, drill a hole through the bolt, stick a cotter pin through. Caveli, small spring on the screw head side and a C-clip on the other side.
Oh, the cotter pin could sit here.
Yeah.
Only problem is that we need to have this slot here, so the pin would need to be a circle clip.
Yeah, C-clip.
C-clip. Here we go. Circlet clip. Is that what people mean with C-clip, you think?
I guess so, right?
That's the solution. So let me show you why I love, this is a great demonstration on why I love to revolve plane sketches, because now we want to cut a little groove in the screw, and that is too easy from here. So I can just cut this little groove for the C-clip. There we go. This
Something like this?
This is the idea. Here we go. Gretzky's in the chat.
You use something like that on the MMX, right?
Yes.
Yeah.
I have 100 million.
Great.
So we might have to custom machine this. It's not a big deal. So I just make this little pocket here with some ugly CAD. And when I revolve, I just do not revolve that little thing and look at our beautiful circular clip thing we have there. And let me... Oh, thank God we solved.
I think it's called Circlip.
Is it not circlet clip?
No.
Circlip.
C-I-R clip.
Circlip.
Or just C-clip.
C-clip. I'm just making a sketch of the C-clip on this little plane. Boom, boom, boom.
C-clip with a washer.
Oh, you want a washer for retaining the... Yeah, so the C-clip, good idea. C-clip with a washer so the C-clip can't get caught on the edge of the slot. Very good idea.
Lucas Sokol.
Lucas Sokol, official Gretzky.
Oh! In the Hall of Fame.
Not in the Hall of Fame yet, but
Okay.
probably
Getting
going there this season. Yeah.
Getting there.
So again, virtue of having this CAD, we need a place for a washer here next to the C-clip, and then we're just moving this over, and we're making our washer.
That's great. Then you can take care of my laundry then. Da 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 da. Cheers. I'll be here all day.
The washer is that I don't care. It's that witness. Witness.
Witness me.
Witness me. New component. My friends, this is fun. This is fun. So let's revolve our washer. This one. Around this one. There's our beautiful washer. And now let's go back to sketching the C-clip. So let me just isolate this.
People are worried about the rattling noises eventually caused by all the C-clips.
That's a good point. Yeah, that's a good point.
Martin Raspaud, a single bolt inside the POM reader or tapped Delrin will be simpler, I think.
A single bolt in the reader. So I don't think, since we're gonna adjust this several times, I'm not sure we want to rely on plastic threads for that. I actually think that it would suffice, but I don't know. Here's our beautiful C-clip. That's the C-clip. Those two holes are for the special tools that pull them apart when you put them on. Then they snap in place and they just sit mechanically still. So washer material, something that doesn't rattle, perhaps?
First name, last name says use nylon washer.
Yeah, genius mind thing to say. And there's a continuation of that quote. And others not so differently or something like that. Nylon washer. Let's add that to the name. Nylon washer can probably still rattle and make a plasticky sound.
Brian Denise. Martin, maybe I'm wrong, but I think you're making a mistake. The space is curved, but the bolt is straight. The registrator pin will get jammed.
No, that's why we have the slot here. If this was a perfect hole, so the head will not sit perpendicular to this surface. So you can see here, the bolt is actually tilted. You can see that the space up here is a little bit smaller. And so the bolt will swing with this motion. If we also look at this radius, I think the bolt will swing 0.1 millimeter or something. So it won't stuck. It won't stick. But my slot is the wrong width. Let's add 6 millimeters here.
Ojumon, will those eat the noise? ? Is he referring to our great belt?
That are preying on the noise? Probably. So yeah, this might not be this doesn't look super elegant now, but I'm super happy that we have a mechanical solution with no springs. And I think this is a much better design than on the first machine. Let's just tidy this up a little bit.
Let's. Can use the washer for that. People are adapting the new word we found in here today. It needs more withness.
So it looks huge right now, and I don't know the materials and stuff. We could make it stronger by connecting it down here. Let's do that. We already made an extrusion feature like that. So let's just make a little 4mm connecting wall here as well. Currently, I don't know the material, as I said. Oh.
FL3UE3 warning, be sure to have enough space for circlip.
That's a good point.
Do you definitely have access enough to apply the C-clip during build?
Ooh, that's a very good point.
That was from Benjamin K.
Yeah, that's a very good point. We have to... yeah, that's not super easy because you can't... The whole idea with the C-clip is that you can't put it on when the bolt is on the outside of this thing. It would be if this thing screws on somehow. Very good point.
CH Crane, nylon washers between all metal surfaces where possible, i.e. bolt heads and other surface.
So I'm just strengthening this thing over there. And I think that point about the nylon washers is worth a visit to our... this is the problem I had with Fusion 360 in the beginning stream. Let's go over here. Nylon washers galore for noise reduction. I don't know if how soft nylon washers are. Like
Gus Van Mar, like someone suggested, I would use E-clip. They don't rattle because they clamp the shaft and you can install it instead of with a C-clip.
Okay, can you pull
Is that
up?
some? I recognize this from the MMX as well, right? Something like this.
Oh, you used... Oh, is that an E? Wow, cool.
E-clips.
So you just push it on. That will be easier to push in place when the bolt... Okay, interesting. Are they equally trustable? Probably. Probably the industry have solved that issue.
Probably someone has done something like this before.
C-clip or E-clip?
Yeah.
I'm learning... I learned something today. Or E-clip. Thanks for that. Interesting. So you just push them. So for example, because we were worried about the assembly, a C-clip would just be to push it in from the underside here. So I've used the wrong wall for this sketch here. As you can see, they're not flush against the walls. So let's head back to this sketch and realize that all this jazz has to be over here. And when I did that, all the parts moved over there. And let's color things a little bit so we can see. Nylon. What color is nylon? White maybe? Oh, that's elegant. A mechanical, no springs, a mechanical lock. And I like it. Although I don't know how to make this part yet. This is the principle anyway. Imagine when we're having 60 of these next to each other and we can just... where did this go? Oh.
Here's something informative as well. You Becca64. All your home appliances, anything with moving parts, use a ton of E-clips.
Oh,
Okay.
that is very good. So the correct E-clip into the correct groove. If they put it like inside home appliances, they don't want issues with that like 10 years later.
No.
Means that it's a solution we can trust. Cool. So let's make it official. E-clip.
E-clip.
And then of course we should then make it look like an E-clip as well. The E-clip doesn't have these holes.
I need to run out for a quick while.
Oh, are you getting thinking oil?
I can refill our thinking oil.
Oh, I already had it. Sorry, I forgot it. No need.
Maybe it wants some reheating though.
Oh, can you do that?
Can't have iced coffee, you know. BRB.
So here's my E-clip, my stylized E-clip for now. That's a good representation, I guess. So what kind of materials would you think this this could be made from simply? Wait. Maybe we don't need two walls. What if the part that would give it a little bit of a sideways? I'm just thinking a more open design where this front wall is not needed. That would probably... Because we want to be able to build this small. Now I'm thinking maybe there's a solution where the Delrin rides on one of those. And the programming pin hits immediately under center here. And the adjustment is off center. But as I said, the main idea is to have something that is very easy to adjust. Let me show you what's happening here. When we move this black part back and forth, it will follow the curve of the programming pin, meaning the programming pin will always hit this black surface perpendicular, which I think would be great. So yeah, I think suggestions for kind of making this part small and simple. I'm thinking of if we only had one and the adjusting screw was to a side, would that actually matter? Because the load would... I'm going to show you my idea. So now I want to make almost the exact same thing. Let me try to just copy this and paste new. This works sometimes, sometimes not. So now I'm in a completely new version. So let's start from the beginning of this one and show you my ID with only one. So this is the one. something like this. And I'm going to delete this copy paste, delete. Yes. And I'm going to edit this extrusion feature and deselect that profile and extrude forward instead. This is going to be the place for our little slot. Oh, the slot kind of accepted this. Nice. So now I want this part to be extruded in the middle of this thing. So let's redo this extrusion feature. Let's just fix the offset here. Let's just extrude it from the profile plane. And we're actually going to extrude it symmetrical for now. Like this. Okay, so now the bottom curve here needs to be curved as well. If this works, we would have full access also. Like we can use a circlet clip here because we are not, the wall is not in the way. So this bottom line now needs to become the radius from the center of the programming wheel as well. Do, 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 do. Shout out to anyone who was here during the horror show of the morning stream. It was... Probably some of you have heard this analogy 100 times already. Sometimes it feels like you're climbing a stair with very long steps. You have to move further on these long steps before you can take a step up. Songwriting is exactly like that. You can work in the studio like a whole day and you feel you did nothing. And then you come back the day after and the song is just there. And you don't know where it came from. Let's do this. What happened to our beautiful radius? Oh, it's the extrude command. Huh? What happened to our radius? Didn't we make the radius? My empire of dirt. I'm hearing thinking oil delivery incoming. Oh no. Oh, I'm back in the... Sorry, I was back in the copy.
Sir?
I was in the wrong one. Jesus, I'm stupid. Thank you. Thank you. I choose the wrong master. Okay, now I know what I was doing. I have two almost identical copies of this, two versions, and all of a sudden I started to work in the wrong one. Stupid, but understandable. Here we go. Order is reinstated. So probably immediate thing against this design is that this is not an obvious slot to cut in this part. But bear with me, let me just try this. It's a huge mess. Edit feature. Yes. Thank you. Yes, good. I'm trying to make it a little more elegant, Hannes.
What? Quick and dirty does it. Okay, did we run into any problems?
Well, while you were gone?
Yeah?
It's this one. Let me delete this feature. Delete. Good. No.
No? Everything is
think
perfect?
So. I do not think so. Now I'm going to cut this thing out of the POM reader. And this is, of course, an impossible machining operation. If you want a curve, you probably do not need a curve. You can cut a rectangle in this and it will be fine and fine. To this object, and we're gonna cut, and the part we're gonna cut is the POM reader only. Dee 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 dee. I just want to demonstrate. So what does people think about the one layer version? If you see where I'm going with this,
The one layer version.
Of course, I should do this.
Cut it in 2 halves, like icon says.
Yeah, that's. And then you have to put them together somehow.
Inuyasha, what is he actually making right now?
Good question. We are making a better version of this because this was hard to adjust the timing. Every time I adjust the timing with adding shims, I couldn't replace this in the perfect position. I didn't really know if the timing was adjusted because this sat in lower, which ate more of the programming pin, which made the marbles play faster. So basically, I'm trying to isolate the function here into being like completely isolated. So here you can see there's a slot through this black thing, and it rides on this metal rail. And now we have to add the screw.
Luke Maffey, I like one layer.
Okay, cool, Luke. Me too.
First name, last name, you might end up with twisting stresses.
Yeah, so the programming pins are still going to hit here, right under this. So the programming pins hit here. And the twists will not be on the screw. The screw will be on the side. Yeah, there will be some twisting, but maybe it's okay. Let's check this sketch. Let's put the slot maybe a little bit more there. Comme ça. Like this. Let's edit this sketch, which is the hole in the POM, I guess. Let's put it somewhere where it makes sense. Here. Look at that.
Desert Pillar, single wall is better from the perspective of it being possible to insert the Delrin, which is not possible on the 2-wall version. Blinking smiley face.
We addressed it Yeah, okay, when I put this wall in, it's not possible anymore. That's You're right. You are absolutely right. And I think single wall might naturally be sleeker. Yeah.
Eduardo Albergaria. I am not sure about the scale of that. Can you give us something for comparison?
Oh, that's smart. It's way too large right now. This is the programming wheel. I'll insert a 16 millimeter marble.
Yeah.
For comparison. Create a sphere. Here. 16. Here's the marble.
Okay.
And I want to use precision pins. So I'm also going to add down here maybe the correct size programming pin. So let's say it sticks, I think we're going to use 3 millimeters precision pins. They're going to be very small. Look, 2 almost, I guessed that one. 3 millimeters. Let's say it protrudes 10.
And Rick Tegelar with the important question: will you leave room for some decorative washer stacks?
No.
No. Okay.
Washer stacks is a thing of the past.
They will be the opening act on the world tour.
Now I have the same graphic card crash in Fusion. No, I want to show them this.
Okay.
This horror show. Because it actually worked. This is a graphic card crash that I was researching before. And I haven't found. People say they are changing their Radeon graphics card to get rid of it, and I think that's what I have. They changed to NVIDIA, and then it worked, or something like that. So part of this morning's horror show was a black screen, black screen of death. So let's say total length of the pin is, I think, here. I think it's protruding like 15 millimeter down, something like that.
And Martin,
yep.
Can we get a save?
Yes, saved.
And can I get a cheers from you?
Cheers, Hannes.
Cheers.
Cheers, everyone.
Cheers.
Let's get this show on the road. You heated my thinking oil. You heated my thinking oil.
No great ideas come from cold coffee, right?
True. True that. That looks better. So why now is this not parallel? Is this not? Okay, that was a constraint I was missing. So now let's just revolve this programming pin for scale as well. It's a good point from someone in the chat to provide some scale. Let's make a new component.
There's so many new t-shirt ideas here.
Precision.
Mike Perry just said, will save and cheers become a new shirt? So a lot of brilliant ideas coming here.
Save and cheers. It's actually a very positive message.
Number one should be, it preys on noise, right?
That's the pin. It looks like it's protruding too much. It preys on noise. That was hilarious. Someone missed it. It's the commercial tagline for the belt we're using. They made an fantastic.
I mean, the tagline just hit our hearts immediately. It preys on noise.
We should say the same about nylon washers. They also prey on noise, right?
How does that sound then? Nylon washers. Doesn't have the same ring to it.
No, the eagle. We need the image of the eagle to really get into it. Okay, here we go. Let's move forward with... So let's ignore the timeline. I'm just going to move these things over. Some CAD days I feel in control, and some CAD days I'm running after an airplane that is lifting, trying to get on board. You be the judge of what day I'm having today. Where is the nylon washer? Here it is. Beautiful. E-clip bolt. Move all this gloriness over. I can and I should center this. Point to point. Choose that thing. Choose this thing. And then let's just... We have to fix this sketch. So it was actually really hard on the previous registrators when I didn't know, when I was adjusting them, I didn't really know what I had adjusted. And it took a lot of time. I was dropping the shims into the machine. Now we can just go up, move a screw, and that's it. Turn a screw. So let's do some children close your eyes. CADing here. I say that every time I'm using bad CAD practices. So basically, maybe we should have the South Park disclaimer. This should not be viewed by anyone. Okay, this is... I like this. Doesn't this... So now we should have two ones to compare with. If I hide this one. So here's the double one, where we had problems access and also the POM reader can't get in there. We could if we cut this wall open, so... And then we have this one.
Mm-hmm.
What do you think, Hannes?
Form from function, right?
Yeah, I think so. Let me... Somewhere this got filled in. Hole up here. Let me just find what happens here. Oh, yeah. I fooled myself by... I fooled myself by copying this design. I never do that. So there we go. So if we think that the programming pin is hitting the middle under here, it's not doing that right now. I think all the twist stresses that we talked about previously will be taken up by just the fit of this POM thing on this thing. I like this. I think it's good.
Boom!
I think it's really good.
Då klubbar vi det beslutet.
We could even... you could even say this part is unnecessary. Have you seen how elegant this turned in all of a sudden?
Ooh.
I mean... seriously. I'm seriously. Now, but check this out. Didn't that just turn the whole design into something elegant?
It flows.
Okay, so let me... Okay, I'm getting a little bit prouder by the moment here. Let me... Don't look at my broken timeline, okay? I saw you
Look
peeking.
away! Look away!
It just should be viewed by no one. I'm happier now, Hannes.
Yeah, you're radiating.
You look like you're golden, so I don't know. Okay. Let me do it this way. Let me do some cheating. Let me do some ugly stuff. I just want to offset some lines.
Yeah, someone said Jonathan Carlson. It's almost like a musical note now.
Oh, that's cool. So if I do this, this is really, really ugly, really nice. So I have two distinct different modes of CADing. When I'm trying shapes, I just go. And when I'm trying to make a parametric good design, I know how to keep things cleaner than this.
Don't have to excuse anything in front of us. We won't tell anybody. We won't go to the CAD council and tell them everything.
I mean, you would be hard pressed to remove parts from this, I think.
Lucas Tuscherer, please round off the edges for sliding the POM part in.
Skating where the puck is going.
Gretzky right there.
There we go. Yeah, so this part could be laser cut metal part with one weld, or it could be a bent. Yes, look at this, because from 24/7 steel that I want to use as a supplier, they can bend this. Oh, so this just, oh, it's beautiful. They just bent this part, so we make a flat pattern, and they bent this little thing up. Let's mimic that by filleting. That's a cool idea. I'm just going to do something ugly here.
Look away, look away. You know the drill.
That's the fun part with these live streams, though. There's no hiding.
Jose Torres, the metal where the POM lies on have to be parallel to the screw, otherwise the POM won't slide well.
That is not true, because we have a slot here.
Yep.
So the screw angles, and if we check on this radius, the up and down motion is minuscule. So let's go in here and see the up and down. The difference from highest and lowest position, if we make a straight line, is 0.5 millimeter. So you would need parts to be extremely tight if that would create an issue. But that's the reason for this slot. I think it's very elegant to ask 24/7 steel if we're gonna make this in steel. Of course, maybe steel is not the correct. Maybe steel is not the correct material, but to have a bent, I love the idea to have a bent thing. Side. Let's go in here.
People are worried about the design, if it will be reliable, and if the bend will create a point of weakness, and the accuracy of that bending.
Yeah, so the good thing with the first of all, they bend with CNC machines, so it's like CNC bent. So the accuracy that we had when we made the marble gates was like very much.
Ooh.
But the accuracy we need here, the whole thing is adjustable, which means it's an old saying from one of my favorite YouTubers. I'm blanking on the name. Schmidt. If you can't make it perfect, at least make it adjustable. So this whole screw is the adjusting mechanism. So if the bending is 0.5 millimeters off, it doesn't matter, because what we really care about is the position of this black part. That's the thing that registrates the musical timing, and that is movable. So we can adjust for any inaccuracies in the bend.
Bend it like Martin. There we go.
So another thing that is not yet in this design is a shear point. So we have talked about protecting the Marble Machine 3 from disaster. And these pins, the magnets we used on the previous machine broke when something went wrong. So I think we need to build in a shear point. And I think the best place to build it is in this POM block. So a shear point is like a point where you weaken your part deliberately to make it break during stress. So let's just CAD that for fun, because we're figuring stuff out. So let's say maybe this would be hell to machine. Wait, we're gonna, from which direction would we machine this piece? Oh, let's say maybe we don't use this thing. Okay, never mind. So perhaps we just put a couple of holes like this. Along like a line. This is truly ugly. I said things were ugly before, and now I'm going to truly ugly. I'm just making the point. Object to PM reader. So the idea here, here's the idea that I think this is actually not a bad idea. I think just drill there some holes next to each other with the CNC machine, and if something happens, so this registrator can't pivot when the programming pin comes, the underside of this PM thing is torn off.
David E has a comment here. Martin, for force distribution, just align the pin with the metal part, not with the center of the Delrin part. Yep.
Great idea. It's almost there. Let's let's put it there. So I'm going to hack that. There. Which also means that this whole part will sit at the center of the programming track. I think kind of this part is done for now.
Yeah.
It's not designed for manufacturing.
Proof of concept.
It's a proof of concept. I showed everyone where it can go. And I think there's one more thing I want to do. I want to simulate the bend. And I tried to create a sketch, but I realized that that's a curved plane. So I need to go into our first sketch in order to be able to do that. So I need to create a straight part here.
A lot of people are asking, for example, here Lucas Tuchscherer, sorry for the name, should the pin not be the breakable part as it is easier to replace? A lot of people are agreeing on this comment.
You know what? Since the pins are going to be, we need to machine the grooves of the O-rings anyway. We could actually machine a break-off point in the pins as well. I would be scared over slowly having them being bent though.
Yeah, and will they get stuck in the...
Oh yeah, they got stuck into the holes as well if the top breaks off.
Yeah, Matt S just wrote that if the pin breaks, you would not be able to get it out of the programming wheel.
Yeah. And for some ways, it feels better to have a plastic being the shear point than a metal. There's something with brittleness and metal naturally being more brittle than POM, that it just instinctively feels like POM will give us a wider range of it feels spontaneously better, which of course says nothing. Okay. Yet again, I edited the wrong version because I have it copied. Here we go. I have to just not extrude this little part. So we have a flat little surface under there. This is ugly CADing, but we're getting there. Side, boom. Now, since this is a flat little surface, I can make a sketch here. So this is meant to symbolize the bend. I want to do the same here. This is a visual reminder that this could be. We talked yesterday on stream about welds versus fasteners, and Team Fasteners won on walkover. Almost.
Landslide.
Landslide victory for Team Fasteners. Welds, not only do they like warp metal parts, but they're also very irreversible. Some welds, of course, but when there's a chance to have a fastener, everyone agreed that that was the best way to go. And making parts from the suppliers that come ready to be assembled is going to be my big thing. So I just cut off the corner here, and I'm going to also fill in the inside corner here. So like when I was working on the Marble Machine X, these repetitive like welding 38 things is like for an inexperienced welder, it's just huge amount of work. I'm gonna extrude it up to this little thing. And now we have an ugly representation that this is a bend. Let's make this larger. No, we're done with this part now.
Ooh!
Let's
Check mark.
Check mark. Let's have a last look at it.
Do we need to add anything to our Excel sheet now? Do we have any, like the bent parts?
We should definitely add it into the PBS just for sake.
Yeah.
Because it feels nice. I like this design.
Yeah.
It's not bad. I don't want this to bend. It would be... Yeah. I just hope this thing doesn't bend, but we can make it larger. It's 100 times improvement compared to the Marble Machine X in usability. So let's go over to our sheet. Let's go to the PBS and let's just enter this beauty. Let's say 07 because it's in the order I create them this time. We'll see what happens with that. Registrator assembly, and we have 07. No, it's actually that. It's actually that one. Bent metal part ? Perfect.
Nice.
Okay, so that was a little W, as they say in the across the pond when it's a win. We take the L for the morning, we take the W for the afternoon. That's just how it goes. So yeah.
Fabrizio Witt, I really like your work and art. Martin and Hannes, you guys are awesome. Cheers from a mechanical engineer from the south of Brazil to you. Never give up.
Oh, thank you so much.
Whoop. We take it.
Nice to hear from you from Brazil. Cool. Just gonna make this... No, never mind. Okay. So, that was it. I think I'm going to move on to something completely different. And maybe I should try to clean up some of the mess we created this morning.
Yeah.
How does that sound?
Sounds great. Perhaps we have some suggestions in our Dropbox.
Oh, yeah.
I can prepare that. Give me 1 second.
Let's look at some suggestions. So our beautiful parametric model. By the way, this morning I decided to make the wheel that is connecting with the flywheel also red. And I actually really love this look. It's the classic, it's so industrial, isn't it? It's the classic like steampunk red. I don't know why they make them red. Was it for everyone to just keep distance to the flywheel that will kill you? Or was it just to this some easily accessible paint? That would be fun if someone knows the historic reasons why flywheels are red. That would be super fun. Maybe red was a code for a moving part or something. But as you can see here, our model has died quite excessively. And we had a crash. I tried to move the loop drum to have more space for some stuff. And things did not end up well. But before going into a new chapter, let's look at some nice suggestions coming in the link from the description. Muted. So here's
Inspired by piano mechanism, a muting system, I guess.
drumstick, slot spring, registrator.
People are saying anti-rust paint.
Anti-rust was red because some kind of chemical.
Rust protection paint.
And it was red because of like some chemical that protected. Why the color red then?
Yeah, probably something like that.
Okay, interesting. I'm not seeing this as simplification. This looks slightly complicated if I don't misunderstand it.
So what do we have here? It's 2 pictures. The first one and then a detailed one.
Yeah, so this is can I see the other one? Credit to Damien Villa who put the name into the image. That's when you get your credits because we read the credits immediately from the image. So thank you so much for that, Damien.
One pivot drumstick. It's named.
Okay,
Fine.
yeah. So this is another. So I think where this doesn't work is that the drumstick can't beat through its positive stop position. It needs to. It can't rest on the drum head when in the moving. So it needs 2 springs. Otherwise, it's working. Otherwise, it's the same idea we've been working on. Oh, I can't read this. Package drivetrain. Can you read it?
Number 1 up there, we have package drivetrain into the drums inside. Single covered timing belt between the drums. Speed controls by levers on each drum. All gear train elements, including flywheel and gearboxes, hide inside clutch for alignment. Then you have gear changes and clutch.
Cool. It feels convoluted. It feels complicated. It's hard to reach everything inside the drums, and then the drums needs to be hubless designs, perhaps. Alternate position of springs in the 2-axis approach. Is there a need to adjust retention springs? Yes. So this is nice from Pursue here. The adjust, definitely. Unmuting hard would also unadvertently beat. So this sketch is actually exactly how I think the design should work. This is what we was working on this morning, and it's a very nice simple sketch. So use the same pins from the programming wheel at the timing wheel, just less bars. Okay. Yeah. What I mean is instead of the triangles, I can pull them up here. You can leave it on maybe the sketch. I can show it next to it. What I mean is that instead of these triangles here, to just use the same pins. But for many reasons, we need the triangles. But the thinking behind this idea to keep things, to reuse the same parts is completely correct. Muting levers in the front would put hands in direct marble path. Consider putting them at the side with a bistable mechanism that drags it would have the added benefit of being where Martin stands. I'm gonna try. So this is skating where the puck is going. I'm just going to find something here.
We have more about the rust paint here. It's iron oxide, aka järnoxid. With the rust paint.
There we go, everyone. We've learned something today. And here we go. These kinds of levers, oh, they're behind the screen. Oh, here we see them. Oh, thank you, Hannes. These kind of levers right there, to the side, Bowden cable push-pull lever. I'm thinking this looks like an industrial solution. It's like for giving throttle to your tractor and stuff. So I'm thinking in my new playing position to the left of the machine, I think having like 60 Bowden cable levers where the Bowden cables just going to where we need the mechanical action is a very good idea. So we don't have to have a physical connection, or rather we have a physical connection, but it's a snake that we can pull. Imagine just taking like 60 Bowden cables out from one lever station and just have them go out like veins. It will look cool, right?
Ooh.
And so if I go back to Fusion 360, I'm already mourning the fact that you won't see the lever from the audience perspective, because if I need to operate, if we're gonna stand like this with the bass guitar, like honestly, I'm thinking maybe we should demirror the machine again. We're gonna see. We need to have all the levers here. So yeah, good point. Completely correct, gauging where the puck is going. But my thing is the Bowden levers, industrial Bowden levers.
Okay, here's some other version of pins, I guess.
Oh, cool.
Yeah.
Use loop wheel as positive stop for beater. Yeah, that will make a sound. So if you do that, you will have a cluck in a big plastic drum every time it hits the drum. And you actually, where beater, this means you need one. So thank Matt for the suggestion, but I think it will make a big noise that we don't want. Second spring could be placed here. Yep. Thank you, Mick. That's exactly the same sketch as before.
And there's a Fusion file, but we also has an image from that file. So he has done something that, yeah, he took the CAD file from this morning and made something. So you also have a CAD file open here later if you want to.
Also, this is why it was a horror show this morning when I couldn't. I named like, I hope no one is like using that as a video as a tutorial for contact sets, because that was awful. Okay, so we definitely need to look at this file, not now, but we definitely need to look at this Fusion file after, because maybe this has been figured out by whoever has sent this in.
Arsenie, aka RS Trigger 003.
So I'm gonna look at this later.
And here we have a little video.
Okay. Oh wait, can I see that again?
I think it will loop here, right?
Oh, it looked like they have solved it. This is super nice with you sending a little video. Is this from the same person?
No, this is from Simon Bianche.
Okay. So they did solve it. Because this is acting exactly the way. Yeah, this is what I failed in creating this morning. Interesting. Do they write how they created it?
No, perhaps he can reach out somewhere here.
Yeah. Awesome.
Then we have Simon Briner, the last one here, a muting idea.
Active, stopper, muting lever. Okay, so for next stream we need to resize this screen because I'm having trouble seeing.
You want a bigger one?
Yeah.
Yeah.
Stopper, active, muted, stopper. I think this is the same idea that we're going for. If I'm... The tension spring is on the other side all of a sudden.
Let's see. Just give me a second here. Let's see what happens now.
Oh,
You know,
yellow.
I can make it a little bit bigger, you know.
So, thank you, Ponir Fasika, for sending this in. Stopper mounting lever.
Okay, RS trigger 003, the model in my Fusion file has exactly the same behavior. So if you open it, look at that, it's the same behavior as in the video.
Okay, cool. That's fantastic. Then I can actually learn from the horror show this morning. I'm so happy for that. Is this another video or is
No,
this
it's
the same
the same
video?
one.
Okay,
I just scrolled up.
okay, cool. Let's check the next one.
We have browsed through everything.
Okay, cool. So, let me first go ahead and repair our parametricness, because what I want to do is that I want to move this loop drum to the back, and that's where we actually took a lunch break when everything fell apart. So let's go from the beginning. And now we know why flywheels are red. It's because of iron phosphate.
No, iron oxide.
Iron oxide has rust protection properties. Abilities sounds cooler though. I'm not as uncomfortable in my skin anymore today.
What's our next project?
Fixing the parametricness of our serious CAD models.
Oh, nice.
Yeah, so I have moved the below, because we had too little space between the lower drum and the kick drum, and so I have moved it 12 centimeters to the left, and things broke. So let's go ahead and see where my parametric things have failed. So here you can see that some circles have moved, and we're gonna find out exactly why.
Iron oxide is rust, people are saying here, so.
They just put the rust on, so the rust couldn't get there first.
Yahoo! You see, we're not as smart as we look, people.
Fusion is working, as you can see here. This is our Fusion waiting screen.
And Simon Bianche, who sent the video earlier where it was working, your model, he says, I just fixed your constraints. And he also said, I'll send another file with an explanation also.
I'm honestly so happy for this education you're giving me, because I had... So the constraints, do you mean the joint limits or the constraints in the sketches?
Let's see, he will probably send us something.
I guess you mean the joint limits. So now let's head over to this sketch that is yellow in the timeline down here. Yellow sketches is like yellow snow. Do not eat it. We learned that early as kids in Sweden. If snow is yellow, try to not eat it.
Yeah. Public announcement right here on Wintergatan Live.
Why have this moved? This freaks me out. This should not... What is this? What is this? What is happening? Huh. Wait for it. Do you remember, Hannes, when I was going on and on and on about fixing your concentricness?
Oh,
Do you
how
remember
could I
that?
ever forget it?
Yeah. I was on that forever, right?
Yeah.
I've been banging that programming drum. And because you see the yellow sketches here, purple sketches, they have moved correctly, but my black sketches have not followed. And that, green. I'm ashamed of myself.
Don't be.
It's the green. I cheated.
Oh no. It caught up on you, didn't it?
Of course, I can't make a green tooth pattern. So green is a cheating way with your sketches. I locked it with this, and now I know why my model died. Okay, this is a beginner lesson. I have to remove the green things, and then we can repair this. Okay. So let's first turn all the lines blue and then try to make them black.
One color at a time.
Yeah, and look what happened now. Now they're trying to fix it and my tooth is broken. Ooh.
Ooh, a dentist appointment coming up.
Oh wait, I know what to do.
Scream in panic.
Dentist appointment coming up. The tooth is black. Okay. I'm with you now. Hannes Paradis. Let me try to make emergency dentistry on this one. This looks okay.
Here's something to cheer you up while you're fixing your mistakes, Martin. A comment from Gabriel Cedres. Martin, I missed you too much. I wish you the best with this amazing project. I followed you from the beginning, and this time without you was very sad. I love your hard work. Boom. Thank you, Gabriel.
Thank you. Thank you so much. It really means a lot to hear. That it's a little bit it's a little bit of a new self-esteem in this project, that this the thing you said about hard work. Like, I'm very proud that I can show that I'm not giving up until it's time to give up. And it's not time to give up yet, people.
No.
We can make this work. So what I need to do now is that I need to get this tooth shape to be black. And it's a little bit of an ugly tooth shape. So let's see how I can do this. No. My carefully planned parametric design has already broken down.
So this is a moment of silence here for your parametric designs, right?
Yeah, they
will be missed.
they were with us for 1.5 whole day, but we will never forget the time we had together. Things were following global parameters.
So what are you doing right now? You're just redoing or fixing or what's happening in front of our eyes here?
Yes, good, well done, demon director over there, providing some context. I'm trying to keep these CAD files parametric, which means that we can move things around. And my mistake was that the tooth for this gear belt was not black. All lines needs to be black. It was green. I locked them in place and forgot about it. And now I'm going to try to constrain this in a way that it can move around. So purple is also okay. And this orange here is a trick because it's actually from a derived design, I think. Is it not? Maybe it's not. Oh, look at this. Everything falls apart in front of our eyes.
Witness me.
So, what happens if I delete this? Okay, good. Good riddance. Splendid riddance. Going to do this. So this tooth is for from the pulleys. I'm going to. I know I'm going to redo this one day, but I just want the. Is this a curve? What is this? What? Oh, so we're in a different plane. Okay, that explains some stuff. What is this? We have... Okay. What is this? I have inadvertently created a 3D sketch. It's a classic stupid mistake. That explains a lot. So let's not connect those two. But why is this in the same sketch file? Because it doesn't say 3D sketch here. Things.
You know what, Martin? It might seem like you don't know anything right now. Just let me read this then from Alarmaji. Welcome back. Very glad to see you continue. Your whole journey with the MMX and YouTube should be mandatory learning material for engineers. Thank you so much, Alarmaji.
Thank you.
And Fabrizio Witt chimes in, Alarmaji, 100% agreed. I've learned much here and I am an engineer myself.
Yeah, that's awesome. That's awesome. I just hope I'm learning something as well.
We are getting there.
So Fusion is
a bit cranky today, perhaps because we just did so many cranks yesterday.
So yeah. There's another way to do this. It's to just design these a little bit more advanced stuff with like 200 gear teeth and stuff, like these herringbone gears. Around the midpoint of an origin, move it around with joints. It might be over. There's a big chance that I'm biting myself in the foot in moving these kinds of advanced things around. So now I'm like questioning the foundation, how I built this CAD design. Again, I restarted 4 times in 4 days. So this will be a reoccurring theme. And I think everyone out there who's CADing recognizes this situation. So for advanced components, it might, because this comes from my fear of fusion joints. But I'm jointing this in place anyway. No. Loop drum, it's actually CADed in place. Honestly, this was actually just a CADing mistake. Let me try to fix it. We're gonna see. So
Camille 13. Could you rename extrude 4 to something like answer to the ultimate question of life? So it will read computing answer to the ultimate question of life instead.
that will be great. So I'm witnessing something that I've never seen in my fusion life. Normally when you have stuff in 2 planes in one sketch, this box is ticked 3D sketch. So if I'm not misreading this, we're looking at one sketch with sketch in 2 planes. But the 3D sketch box is not.
Come on, Gretzky's out there. Perhaps you can see where we need to go.
Yeah, this is a horror. This is another horror show, Hannes. Oh.
Oh no.
I'm not. This is another horror show. This is another horror show, my friends. Do I have to really do this one from scratch? What are you doing over here?
You might think it's a horror show, but it's actually a nice comedy for me over here.
Yeah, it's like a Greek tragedy. Yeah, people love it. Okay, let's take it as a fantastic lesson. Let's drink some water and let's CAD this part from scratch.
There we go.
And let's make it with some more beautiful constraints.
Jeff Matson. Martin, you probably need to clean up your history hierarchy. Did you ever learn how to do that?
Ooh, no.
History hierarchy.
That's interesting. Good idea.
Sounds badass.
Let me do a quick Google on that.
Do it. Let the people see what they really came here to see. These 2 beautiful gentlemen sitting right here.
Normally you leave that judgment to the audience, but okay. Organize design history Autodesk forums. Stuck on a workflow. History hierarchy.
Jeff Matson, no Autodesk causes ghosts like this when you think you deleted something you haven't. And I'm with Inuyasha here. Why do components have a history? This is so confusing. I'm with you.
I'm gonna try something stupid here. I'm gonna move this from this point to this point. Maybe it wasn't so stupid. Okay. Maybe some dignity has been restored. So now this sketch look like a sketch should look in one plane. I have no clue what happened there. I would love to learn about the thing you mentioned with...
History hierarchy.
yeah. So let's try to save this if possible.
Jeff Matson, I used to have a job cleaning up people's animation work. Okay, so he has done this before.
That sounds really cool. So now if I can just turn this little triangle black, we have made some progress. It totally makes sense that I couldn't do what I wanted to do before since the components were not in the same plane. So no surprises there. So what I need to learn, also really need to learn in these streams, is that some jobs you can never do stressed in CAD. And like some jobs are just meant to be carefully done. So now I'm going to try to calm down and do this carefully. So now I can add this constraint, progress, result, like Ricky Gervais would have said. So, result. These are not beautiful, but I've calculated this gear tooth size. We have yet another black line. Result.
Oh, we're getting there.
Is this not... oh, this is not...
No, don't be hasty.
no, don't be hasty. We have yet another black line. So funny that I left this sketch green and then tried to brag about how parametric my new CAD skills are in the stream like this was it yesterday? There was this morning and Fusion crashed and I was like, I think it was
Stupid Fusion.
Stupid Fusion. Okay, I'm feeling it. I'm feeling it now.
Yeah. Javinsky, this live stream was very parametric. Boom.
I don't know. I'm not sure exactly how to take that.
It sounds like a compliment.
Yeah. Take it as a compliment. This is still early days. Early days. Oh, look at that. Everything is black. And now let's see if we can just recreate this gear. A little bit. So this should be this. And we have to choose this. Okay, we're getting somewhere.
Yes.
We're getting somewhere. Cleaning up CAD is this plane is missing its line. So I have to re-choose that. So, I should actually go over to this screen. What I'm doing now is that I'm cleaning away all the yellow snow down here. By editing all the yellow features and just see if they are. So let's see what's wrong with this one. Review warning. Project source is lost. That makes sense. This line, so yellow lines is the same thing. That's like yellow snow.
Okay, don't eat it.
So I'm not going to eat that one. We're going to make a new beautiful purple line. And this is 75 degrees because that's the angle of the herringbone pattern. And then you see now the sketch is clean again. Our sweep. Let's edit this feature. Missing profiles. Okay, good. Circular pattern. So you can see that Fusion is trying to make the teeth, but it's making it along a previous axle.
Yeah.
So let's just edit the feature and let's choose the correct missing axis. Let's choose this one.
Oh, snap it into place.
Snap it into place.
Computing sweep. Whoa!
Good, Fusion. Didn't even get to the second chord. Mirror. Oh, mirror is working. We have our herringbone back.
Nice.
Like patience, you know?
Yeah.
Is
virtue.
So this move command, we have to move. So that gives me an opportunity to show. Yeah, the axis is not there. Maybe if I choose the axis. So I want to shift it one gear tooth. And this is a pretty cool trick. So you can see the gear tooth are alongside. And how did we do it? We did 360 divided by 200, because we have 200 teeth. You put that in a parenthesis, and you multiply that number with a half. Boom.
Oh!
So that's like, for me, who's not good, I'm seriously not good at math. So when I figure these kind of things out, I'm very happy with myself.
Genius.
That's half a tooth right there.
Yeah.
So now you can see the herringbone pattern is doing this zigzag thing, tractor tire thing.
Yeah.
And now we have to combine these two parts into one. Yeah, that worked. Good. And now Fusion is still trying to extrude the wrong profile. So this should be a simple fix. We want this little thing as well. Five millimeter, that's just the clearance for the timing belt on the edge. And now this is also going to be the wrong profile. No, that's the correct profile, but it's filled. What? Ah, that makes sense. Offset 5 maybe? And the distance, what's happening now then? Why can't I choose it? Something is wrong here. We have to do this twice, Hannes. That's why.
Have to do this twice.
Yeah, we have the other drum that went wrong in the same way.
Ah, fun times. That's nice. That's nice.
Sometimes when a feature breaks like this, it's better to just delete it and
Redo it.
and redo it. This and this profile. Start with an offset of 5. But I do feel these complicated designs should be catted on the origin point. And they should just be moved around in another way, so to speak, if that makes sense.
Yeah.
Because this is a little bit of a horror show in itself.
But you know what, Martin?
We're learning.
I think we learned something today.